It entered our solar system from the darkness beyond the stars, an object named 3I Atlas, arriving almost as a whisper in the cosmic wind. For decades we believed interstellar visitors would behave like comets, like debris from distant systems, predictable in their motion, dull in their story. But when 3I Atlas slipped behind the sun, everything changed. What emerged was something far stranger than any natural rock or ice chunk. Today we follow the clues, the anomalies, and the unanswered questions. Welcome to the story of 3I Atlas. Astronomers first flagged 3I Atlas because of its hyperbolic trajectory, meaning it arrived from outside our solar system, not bound by the sun's gravity. That alone is rare. But then, as it approached the inner system, things got weird. No slow fading, no predictable outgassing. Instead, data showed brightness surging, detecting pulses and emissions that did not fit any known comet model. Ground-based telescopes and space observatories watched as instrument readings began to diverge from expectation. The object should have been losing mass, sublimating, fading. But 3I Atlas seemed to grow stronger, as if something internal or external was turning it on. Then the critical moment, 3I Atlas passed behind the sun. Because of the sun's blinding glare, many Earth-based telescopes lost sight of it. But during this hidden phase, something remarkable happened. Radio sensors, solar monitors, and coronagraphs began picking up rhythmic pulses, faint, repeating every 7 minutes. The signals didn't match the usual background noise of the solar corona or standard cometary behavior. When the object finally emerged from the sun's hide, it looked different. Brighter. More structured. Its coma glowed with an odd electric blue hue. Its tail, unusually symmetric. The observable characteristics no longer resembled any known comet. At this point scientists began cataloging what I'll call the 9 major anomalies of 3I Atlas. Things that individually might be explained, but taken together challenge our understanding of what a natural object can do. It followed a hyperbolic path, but the arrival direction lay very close to the ecliptic plane of our solar system, a very unusual coincidence. Subtle thrusts, small deviations from the calculated path. The brightness increased much faster than standard cometary models predict. At times the dust stream seemed to point toward the sun rather than away, opposite the expected solar radiation pressure outcome. Spectral analysis suggested unusually high nickel content relative to iron, and extremely low water ice fraction. Light scatter from the object gave polarization patterns that didn't match comet families we know. Imaging hinted at geometric thermal zones, hexagonal hotspots, rather than random patchy sublimation fans. The same behavior had been flagged during previous close approaches, e.g. near Mars, and now again near the Sun. Weak radio or optical pulses repeating at fixed intervals, almost equals 7 minutes, recorded by amateurs and professionals alike. So what are the viable explanations? On one side, a comet or asteroid from another star system, behaving unusually because of composition or solar environment. On the other, a probe or machine, artificial or semi-artificial, that has been awakened or triggered by its encounter with the sun. The natural explanation struggles. If outgassing is driving the thrust, then the mass loss should be dramatic. Yet the observed trajectory changes are too small and too controlled for a random jet. The structural geometry suggests something engineered rather than naturally evolved. The technology hypothesis remains speculative. No confirmed radio transmissions, no visible appendages, but the anomalies line up too neatly. If it is artificial, we might be witnessing one of the first technological interstellar visitors ever detected. Why should we care? Because 3I Atlas forces us to question assumptions. What if interstellar objects are more than frozen leftovers of star formation? What if they carry active mechanisms or purpose? For the near future, the world's observatories, including the James Webb Space Telescope, ground arrays, amateur observer networks, will track Atlas as it leaves the inner system. If controlled acceleration continues, if new pulses or signals appear, we might have to reconsider our place in the cosmos. Even if it turns out to be natural, it is by far the most bizarre visitor we've observed. And what we learn will reshape comet science, interstellar object studies, and our planetary defense frameworks. For now, 3i/Atlas drifts outward, silent, watching perhaps. We don't know if it came to learn, to observe, or simply by chance. But what it does do is invite us to look beyond comfortable models, to expand our curiosity and sharpen our tools. In the coming weeks, months, and years, keep your eyes on the skies, your sensors ready, and your questions bold. Because when something that shouldn't exist shows up, you'd better pay attention. If you enjoyed this deep dive into interstellar mysteries, don't forget to like, subscribe, and hit the bell so you don't miss updates when new data arrives. Until next time, keep looking up and keep asking why.